Hi, I'm 218. This is the moment you've been waiting for, the moment we leave geometry behind and head back into the Algebra 1. So first up, we're going to talk about graphing lines. We have three different forms that we can write the equation of a line in, and we need to graph all three forms. So the first one, this is slope-intercept form. This is the one that most people are most comfortable with, where you have a y-intercept at the end, that's this value right here, and you have this m value, which is your slope. Okay, so take a look at what I filled in. So our starting point is this y-intercept right there. Okay, it is important to remember when we talk slope-intercept form, this is the y-intercept, which means it's on the y-axis. It is not an x-intercept. So B is the point that's on the y-axis. So that's what I'm calling our starting point. For every line that we're going to graph, we need a point, we need a slope. So the point is 0, 1, that's this point right there, okay? You start at 0, 0, you go up 1, and then my slope is 3. So what am I going to do with that 3? I'm going to make that 3 over 1. So by making that 3 over 1, I now can see that I'm going to rise 3 and I'm going to run 1. Okay, so take a look. From here, I'm going to go up 1, 2, 3 over 1. There's my point. Up 1, 2, 3 over 1. So really all I need is 2 points in order to make the line through them. I usually make a third point, and from my starting point, so starting at my y-intercept, I usually try to get at least 1 point on each side. I figure the more points I have, the straighter my line will be. You, of course, can use your ID as a straight edge, but I do expect a straight line. And again, to be clear, I would like you to have not just your y-intercept, but at least 2 other points. So they could both be on the same side of the line, same side of the y-axis, but I think it's better if you try to get at least 1 on each side of the y-axis. And there you have it. We just graphed a line in slope-intercept form. Okay, so new problem. We have a new slope, we have a new y-intercept. It's still slope-intercept form, still y equals mx plus b form. Why don't you pause the video here for a second and see if you can graph this new line. Okay, how'd it go? Did you get your y-intercept at 0, negative 3? So starting here, going down, 1, 2, 3. Were you able to calculate your slope as up 1 over 4, up 1 over 4? Or if I go to the left, down 1, left 4, down 1, left 4? Hopefully your line matched my line and you are now confident and ready for one more of these. So here we go. One more. Okay, still slope-intercept form. I just want to make sure we talk about every possibility out there. What happens when your slope is negative? So pause the video, try to graph this line yourself, and we'll see if yours matches mine. Okay, how does yours measure up? Did you find the y-intercept to be at the point 0, 3, which is 1, 2, 3 up from the origin? Were you able to figure out that the slope was negative 2 over 1? So down 2 over 1, down 2 over 1, and let's talk about that for a second. Okay, anytime I have a negative slope, I always put the negative on top. I never put the negative on the bottom. So for me, slope always means run to the right. Okay, I don't care if you go up or down, but you're going to always run to the right for your first few points. So the negative 2, it's not a rise of 2 anymore. Now you can think of it as more of a fall. So from this point, I fall 2, right 1, fall 2, right 1, fall 2, right 1. And anytime I teach Algebra 1 and teachers graphing, I always teach to get the points to the right of your y-intercept first. And then once you have a pattern, now I can go up and to the left and up and to the left. So take a second, make sure with the negative slope that your line still matches my line. Okay, so this time, let's take a look at an equation in point-slope form. What is point-slope form? Well, it still has the slope. There's the slope. But the point is not necessarily the y-intercept. The point now is x1, y1. So I have to look at this one with numbers, okay? Pulling out the slope is now the easy part, because now we got to think, well, what is the point here? Okay, the point, I know it's going to deal with a 1 and a 3, but look in the equation. In the equation, it's got these negative signs. You could think of these negative signs as taking the opposite of what's there. So you're going to be tempted to say the x value is 1, but it's not 1 because I have to take the opposite of this 1. So my x value is going to be negative 1. And the same thing holds for the y. You're going to be tempted to say, oh, it's at negative 3. But again, the minus sign has to be there, so the y value is just the 3. Okay? An easier way of looking at this might be to take a look and say, okay, let's take this x plus 1 and let's just set it to 0. I'm having a really hard time, but I can always set this quantity equal to 0 and solve. So when I take x plus 1 equal to 0, I get negative 1. When I take y minus 3, set it equal to 0 and solve, I get y equals 3. Some people would rather say just take the opposite of what's here and take the opposite of what's here because they understand the equation. And some people really just kind of need to see the equation until they try a couple out for themselves. Okay, so no matter how you think through this, we come up with this point, negative 1, 3. So again, it's not necessarily on the y-axis anymore. This is a shift. This is a shift left, right. And this is still going to get you your shift up, down. But we're adding this component in. So my starting point is negative 1, 3. And my slope is good old 2 over 1. So what does this look like? Here's my starting point. Okay, that's my negative 1, 3. So left 1, up 1, 2, 3. Here's my starting point. And from there, my slope's up 2 over 1, up 2 over 1. Or down 2, left 1, down 2, left 1 if you prefer. Okay, so on a line like this, somebody will always ask, well, can't I just distribute the 2 and add the 3 over and take this back to slope-intercept form? Okay, and my answer to you is yes, you can do that. It is just time consuming. So if we are trying to be fast and efficient, that's not fast and efficient. Fast and efficient is pulling out the point, pulling out the slope, and just getting the graph from that. Okay, so here's one for you to try. Again, we're working in point slope form, okay? And maybe this is a better example of why you don't want to take the time and distribute and move the 5 over, because look what happens here. When you take 2/3 times 4, you get some ugly fractions, okay? It's not worth the fraction work to me. I can pull a point out, pull a slope out, and be done faster than most kids can distribute and get this into slope-intercept form. So take a minute, pause the video, try to figure out what this line looks like. How'd you do? Were you able to find your starting point at negative 4, negative 5? So 1, 2, 3, 4, down 5. There's my starting point. Okay, were you able to find your slope was a negative 2/3, so down 2 over 3. Okay, up 2 over 3 to the left if you prefer. But it should be a negative slope, meaning it should be dropping from left to right. So check yours with mine. Once you're confident, let's move on. Okay, so let's move on to our next and final form. Our final equation here is what's called standard form. Okay, here's the basics of what it looks like. A, B, and C will be integer values, meaning they won't be fractions, they won't be decimals. A will be positive, and we'll get more into the specifics of this form when we actually write equations. Right now, I'm just going to give you the equation in standard form and ask you to graph it. So this is a little easier because I don't have to worry about how to write it right now. I just need to go ahead and graph this. And again, before we start, I know there will be somebody who will get y by itself, they'll subtract and divide and do all of that and get this in a slope-intercept form. And that's fine. As we talked earlier, it's not my fastest, most efficient way. Okay, I don't want to solve and get y by itself, and what if I get those fractions and whatever, but it is something that is doable. Okay, I'm going to give you something that I think is faster and more efficient. So looking here when we talk about, well, what point, right? Every line needs a point and it needs a slope. That's not at all how I'm going to approach this. Okay, so look what I've done. I've rearranged our screen a little bit. I brought the slope over here. Our slope's kind of irrelevant right now. I am going to focus on this equation on getting 2 points. Okay, rather than a point and a slope, it's easier for me to get 2 points, and the 2 points specifically are going to be the y-intercept and the x-intercept. In either order, it doesn't matter. I put y-intercept first because it's easier to put a 0 in the first slot. This is just a regular old t-chart. Okay, I'm going to go ahead and plug in 0 for x. Now, if I plug in 0 for x, that whole term drops out. And then when I divide both sides by 2, okay, I get a y value of 6. Okay, so now I'm going to do the same thing to find the x-intercept. I'm going to go ahead and plug in a y value of 0. If I plug in a y value of 0, 2 times 0 is 0. So that term drops out. Divide both sides by 3, and I've got my x-intercept is at 4, 0. So plotting my x-intercept at 4, 0, my y-intercept at 0, 6, I can connect them with a line. And remember, we said 2 points, that's enough to make a line. So now the only thing I'm missing is my slope. Okay, I don't have to use the equation at all. If I am confident in my intercepts, all I have to do is count. So from this y-intercept, I go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. So negative 6 over 4 reduces to negative 3/2. I have my slope. Okay, my slope is negative. I have my 2 points slope, and I'm done. Okay, here's another example. Standard form, right? AX plus BY equals C. Here's one for you to try. Pause the video now and see what you can come up with. So how'd you do? Y-intercept, that's when you plug in a 0 for x. So if that's gone, divide both sides by negative 5, I've got negative 2. When I find my x-intercept, I'm plugging in a 0 here. So if that term's gone, divide both sides by 2, I got 5. So 5, 0, 1, 2, 3, 4, 5, 0 right there. 0, negative 2 right there. Connect them with a line. Count your slope up 2 over 5. And I'm done. So here we have a newer line, y equals 3. But is it slope-intercept form? Is it y equals mx plus b form? Okay, is it standard form? I think there's a little debate out there which one it is. I probably think of it more as slope-intercept form, but when I introduce the next example, you'll see why most people are going to call these standard form. Okay, either way, I don't really care what form it is. We need to know how to graph it. We need to know what is the significance of y equals 3. So starting point, where is my starting point on that? Okay, what's my slope on that? I think the people who say that this is slope-intercept form will argue that this right there, that is in fact my b value. That is my y-intercept. Okay, so now I have this y-intercept, but where do I go from there? What's my slope? What's my next point? How do I find that? So I'm going to present a totally different approach to this. Okay, so here's the claim I'm making. If the y value is 3, I can set up a t-chart where I put in y equals 3, y equals 3, y equals 3. Every single point in my chart must have a 3 in the y column. Okay, so that's easy enough because y equals 3 gives me, yes, all these 3's. But what do I do for the x values? What do I do for this column? Okay, since x is missing from my equation, this equation is saying x doesn't matter. It's irrelevant. It can be any number you want. Okay, meaning I can put in x as negative 10. I could put in x as 0. I could put x in as 1,000. Okay, I can pick any x values I want. Now, are these the x values I want? No, those aren't very helpful when it comes to my graph. So let's try that again. Okay, this time I'm going to put x in as maybe negative 2. I'm going to put x in as maybe a positive 1. And maybe I do a positive 2. Okay, I'm trying to keep these x values small enough that they're going to show up on my graph. But again, I made these up. The numbers themselves are actually irrelevant. Any x values you want. Okay, so look, I took these 3 points, I plotted them. In addition to my y-intercept, I can see a pattern here. Okay, I can see that they're starting to form this horizontal line. If I want to, I could put more points on there, as long as my y value is 3. So I could have the point 1, 2, 3, 4, 5, 3, if I want to add that one in. I could have the point negative 5, 3, 1, 2, 3, 4, 5. Okay, once you have enough points to establish the pattern, draw the line, and we're done. Now, in terms of calculating the slope, because that's all that's missing, pick any 2 points on the line Okay, and figure out what is the rise. The rise between these points, the rise is 0. So I've got a 0 rise. What's my run? My run is 1 or 2 or 3 or 4. It doesn't matter what the run is, because as soon as I put a number on the bottom, as long as that fraction has a 0 on top, it divides out to 0. So my slope is 0, and I have at least 2 to 3 points on my line proving that it is in fact a horizontal line. Okay, last example. So here we've got x equals 3, okay, and maybe you can see why some will argue now that it can't be slope-intercept form if it starts with an x equals. So maybe this is standard form, but regardless, I just have to be able to graph it. So looking at what we did last time, I know that if x is 3, every single point must have an x value of 3. Y is missing from the equation, so y again could be anything. Okay, so I've picked some y values that at least will fall onto my graph. I didn't want to make them too big or too messy or too anything. I just want some nice pretty points that will in fact show up on my graph. Let's plot them and see what happens. Okay, so plotting my 3 points, or maybe you picked different points, got me 3 points that all stood in a vertical line. So when I connected them, I see the vertical line. Okay, only thing I have left is to figure out my slope. Okay, so picking 2 points, I picked these 2 points. My rise between them, it's a rise of 3, and my run is definitely 0. So the 3 is kind of irrelevant because some might argue if I pick these 2 points, the rise there is 4 or even a negative 4. But as soon as I see that my run is 0, you can't divide by 0. So as soon as we try to divide by 0, we see that my slope is in fact undefined. And there you have it. Okay, we know that x equals 3 is going to be a vertical line. Here's the proof of that. Here's my line, and there's my slope, and it's done.